Okay, my name's ChristineLaMunyon. Thank you so much for attending my master's project presentation. It's going to be on climate change and whiskey production. It's a geospatial analysis of how shifting climate patterns are reshaping Scotland's iconic Scotch whiskey industry. A little bit about why I decided to do this project is because when I was 18, I caught the travel bug. I've been to Scotland a few times now in my life, and I fell in love with the country. I grew up with a dad who loves Scotch whiskey, his favorite being Islay Scotch. It's a little smokier, and so it's a good merriment of interests. So a few whiskey's key ingredients that are potentially threatened by climate change is barley production, maceration process, and water availability. Shifting precipitation patterns may affect availability and the water quality that are critical for whiskey production, as well as temperature changes that are impacting the yields and the quality of barley, which is a core ingredient for Scotch whiskey. There is also potential for fluctuations in humidity and temperature, which may alter the traditional maturation process of Scotch. And that's a crucial process that is developing the unique flavors and aromas of the whiskey. There's also potential environmental changes that could put the future of Scotch whiskey production at risk, as the industry relies on stable climatic conditions to maintain its high standards. So these are a couple of my first reference maps. We have the Scotland regional reference map I created, and as well as the UK districts maps. Scotland is divided into 14 agricultural census regions, as you can see from the reference map, each with unique growing conditions for barley production. And the data for this map was obtained from the Scottish Government Agricultural Census. The country is also divided into 3 major climate-based districts that you can see on the UK districts map. It's Scotland North, Scotland East, and West. They do align with the UK Met Office boundaries, where I also got this data from, the climate data. And whiskey production facilities are also concentrated near the prime barley growing regions, as this spatial relationship is key to the industry. As you can see, I've added a layer on top, a graduated symbol of the highest producing distilleries in gray circles. So the first data-driven map I created was the 2024 spring barley yield map. It shows the distribution of barley yields across Scotland in 2024. The highest yields, as you can see, are concentrated in the Grampian and Tayside regions. Those are in the east. It's where warmer and drier conditions are usually described, and it currently favors high barley production, even with warmer and drier climates. In contrast, the western regions of Argyll and Bute and Highlands, to name a couple, see lower yields. It's likely due to actual excess of moisture, which limits productivity, could cause waterlogging in the crops, and such items seen. Many of the barley producers are situated near these high yield zones, demonstrating their historical adaptation to the agricultural patterns in Scotland. Next, I wanted to look at the rainfall patterns across Scotland. So I created this 2002 to 2024 average annual rainfall map. It's a choropleth map that shows the average annual rainfall between those two decades across the 3 different Scottish regions. So light blue, lower average rainfall, to dark blue is higher. I also created a chart in ArcGIS Pro that shows the different annual rainfalls throughout the 2 decades. And as you can see, Scotland's east to west rainfall divide may be a key factor in the whiskey production, with the west receiving over 1,500 millimeters annually and the east less than about 1,000. The significantly higher rainfall in the west provides ample resources for distilleries in that region, whereas the drier east faces challenges in water availability. As you can see, that is where a lot of the top producing distilleries are located as well. And these regional precipitation patterns are crucial for understanding and managing water supply for consistent whiskey quality across the distilleries. It also highlights the geographic variation in rainfall, which helps explain the unique characteristics that influence the production of Scotch whiskey. And then these rainfall trends set the stage for exploring how distilleries adapt their processes to the local water resources in different parts of the country. So the second part of climate data that I obtained was the average annual temperatures. I also obtained this data using the UK Met Office data sets that were described with the 3 different Scottish regions, east, west, and north. Temperatures have risen between 2002 and 2024 by an average of about 1.3 degrees Celsius. It's about 2.34 degrees Fahrenheit. And that's all across Scotland. That's annual averages. We see this warming trend across the regions, with the west consistently warmer than the east and the north. It's interesting because the west is where there's also seeing a higher volume of precipitation from the previous map. It can indicate instability in the region, and that may beget lower yield production as seen from the percent barley yield map, which I'm about to show you. The temperature changes affect barley growing seasons and maturation conditions in the region, and these regional differences in temperature rise will have implications on the agricultural planning and the crop yields, and then in turn whiskey production. The next map I created as a comparison to those maps were the percent barley yield change. This collects data from 2021 to 2024, and it's across the 14 agricultural census regions from those 3 years. We see a mix of gains and declines, with the average of Grampian and Tayside regions, like in the east, showing productivity increases, where in contrast the south and southeast have experienced yield reductions. It suggests that climate change impacts are not uniform across Scotland. There is quite a large variation, and different regions showing vulnerabilities to both temperature and precipitation, perhaps. The higher rainfall in already wet regions like the south and like the previous precipitation maps that I showed you may be causing waterlogging in the crops and contributing to yield declines. Whereas temperature effects may also be a factor, with warming potentially benefiting some regions while stressing others. And the overall regional differences in the yield trends may highlight the need to understand local climate impacts rather than just a national average. And this way we can have a much more specific barley crop area and analyze that accordingly. I think more data will need to be recorded at a regional level due to the current constraint of only 3 years of data regionally. Everything before 2021 was average data of the whole of Scotland. The next analysis step that I conducted was climate yield correlations. In this, I created a Pearson's correlation coefficient measurement. It it shows the trend lines between climate variables and barley yields. It uses the years of 2002 to 2024. So that way I could capture all of the annual averages for all of the variables involved. So the 2 decades that were previously mentioned. And the scatter plots include the recession lines for the Pearson's correlation coefficient. so that strong and weak correlations can be visualized by the viewer. And so for the key findings for our analysis is that there's a weak negative relationship between the temperature and the crop yields, with a correlation of about negative 0.21. Whereas on the other hand, it's a weak positive correlation between rainfall and yields, with a correlation of about 0.14. So both weak, but both show the trend line increasing or decreasing. And from both of these analyses, I can derive that the optimal climate conditions for maximizing yields appear to be about moderate rainfall levels combined with controlled temperatures, which is due to be expected in Scotland because of its climate history. The reason that there is a Scotch production is due to stable climates in that region. And while the relationships are not strong enough, the data suggests that higher temperatures may slightly reduce yields, while appropriate rainfall levels, especially in drier regions, the ones that are not already very wet and potentially waterlogged, can benefit from the production. And then these insights also may help our strategies for adapting climate change and optimizing agricultural practices. So I do have a couple considerations after all of this analyses. We have some assumptions and some limitations. A few key assumptions is that I assume that the Met Office district level climate data reasonably reflects the growing conditions across each region, even though local variation at a smaller level does or may exist. And secondly, I assume that the barley yield data from the Scottish government were consistently reported from 2002 to 2024. And then lastly, I assumed that the distillery locations were stable over time, although location may remain the same because the distillery is at the same location over time. Productivity levels and production values also may fluctuate in the future. There's also a few limitations. The 2021 to 2024 yield data, the change window is so short, so the trends may reflect short-term changes rather than long-term climate effects. And the distillery data also came from public sources and may also contain minor inaccuracies. It was hard to track that data down with an exact measurement. And lastly, by averaging climate and yield data from the original district boundary to match the regional census boundary, some small scale variations were likely missed since the polygons were not exact matches. And then still, I found that the method was allowed for like a consistent interpretable analysis across Scotland for barley yield. And lastly, implications for whiskey's future. The whiskey industry faces several key implications for its future due to changing environmental conditions, as seen in this project. We're seeing regional shifts in climate zones that may alter traditional production patterns, but some eastern regions show the resilience. So even with the differencing in precipitation and the temperature, we're still seeing yield from those areas. High yield. And distilleries will also need to adapt their water management practices to ensure sustainable access to the critical resources used for barley and also maturation processes. And the barley varieties and farming methods will require development to withstand the new climate conditions. Traditional maturation processes may need modification due to consistency and quality of the product and due to future temperature variations. So that pretty much wraps up all of my analyses and my findings. And I had to throw this last picture in because it's from Deanston Distillery. I was lucky enough to go to that distillery, which is a Highlands distillery, and see some of their aged Scotch barrels and get a pretty cool tour. But that's it. Thank you so much for listening to my presentation.